Previously, we've had videos on the 6 basic trigonometric graphs. Then we had a video talking about how to handle reflections, translations, compressing and stretching, changing the period, and all sorts of things for sine and cosine. This video, we're going to try to talk about how those things apply to the other 4 trig functions: tangent, cotangent, secant, and cosecant. And we're going to start with just 2 examples here, and just as we go along, mention the general rules that you would apply when trying to do whatever other example you have. So this first example says graph y equals 4 tangent of pi x. So you see we have 2 things that are affecting it from the basic graph. We have a 4 in front. Now on a sine or cosine graph, that would tell you what the amplitude is, but the tangent graph does not have an amplitude. And I'm going to draw a quick sketch of the tangent graph. It looks something like this. And it's just that, repeated over and over and over again. But as you can see, it goes all the way up to infinity, all the way down to negative infinity. There's no highest or lowest point. That's why we don't really have amplitudes for tangent and cotangent. The other number that's going to affect things is this pi here. And just like on the sine and cosine, that number is going to affect the period. So here's the best way to go ahead and figure out how to graph tangent or cotangent graphs. First thing you want to do is figure out the period. Now when we were doing sine and cosine, it was 2 pi divided by the coefficient of x. However, for tangent graphs, if you remember, the period of tangent by itself is just 1 pi. So the vertical asymptotes start at negative pi over 2 and positive pi over 2. That's a length of pi before the graph starts repeating itself. And so that's why when you want to find the period of these modified tangent and cotangent graphs, it's going to be pi over the number you see right here. In this case, they're both pi, and pi divided by pi is 1. So that means my period is the number 1. So every time I go 1 unit to the right, I'm going to have a copy of the same graph. Now, once you figured out the period, what you want to do is you want to go ahead and mark on your number line half of that period. So period is 1, half of that would be 1/2 right here. And you also want to do the negative of that. So we have negative 1/2. These are where your vertical asymptotes are going to be located. Next thing you want to do is you want to draw 3 points here. And so the 3 points are going to be the one where it crosses the x-axis, which for the standard tangent graph is 0, 0. And then we're going to draw the one that's halfway out to the vertical asymptote, and that's at pi over 4. And if you plug in pi over 4 into tangent, if you look at the unit circle, you're going to get 1 there. And if you do it halfway on the other side, negative pi over 4 is going to give you a y value of negative 1. So what you want to do on your graph over here is mark your middle point, the x-intercept here. That one's not going to change by this number 4. It's not going to affect 0 because 4 times 0 is still 0. But it is going to affect the next one. So normally the tangent graph has a value of 1 at pi over 4. So when we multiply by 4, it's going to have a value of 4. And that's going to happen right here, halfway to the vertical asymptote. So halfway to 1/2 would be 1/4. And I'm going to go up 4 units here. So that would be the point 1/4, 4. If I do the same thing on the other side, I go to negative 1/4, negative 4 here. And that's my other point. Once you got your 3 points, just go ahead and connect them. And again, that could have been better there, but that's the graph of the tangent. And then if you want to continue this, right, you would go ahead and copy this shape over and over again here. And every time it's repeated, a period of 1. So if this is 1/2, the next vertical asymptote is going to be 1 more than that. So it's going to be over here at 3/2. And each one's at 1/4, so it's going to be 3/4, 1, 5/4, and then 3/2. And this is the general way we're going to handle these tangent or cotangent graph. So you draw your starting graph, either tangent or cotangent. Both of them are going to have 3 special points that you want to draw. Just to remind you, the cotangent graph looks like this. So your vertical asymptotes are at 0 and 1 period out, and it's coming downwards rather than going upwards. You need to use whatever numbers inside the function next to x to figure out your period. And whatever numbers outside, you use that to figure out the y value at those 2 special points. And this process will work for tangents or cotangent graphs. Also, if you have some shifts, let's say you shift the whole graph up 1, you can just do that at the very end. Take every point you drew, add 1 to it. You can also shift left or right if you need to. All of that's kind of contained in the same process. But mainly you just need to understand how to handle the new period and the new y value at those 3 points. For the second type of graph on this video, we're talking about secant and cosecant videos. And what you want to do is, instead of drawing secant, you want to draw whatever the reciprocal of the function would be. So secant, if you reciprocal it, would be cosine. Now you leave the inside number alone, it's still 4x there, and you also leave the number outside alone too, and I'll explain why we don't reciprocal that part in a few minutes. So what you're going to do now is you're just going to draw 2 cosine of 4x. So you're going to go back to the previous video, learn how to graph sines and cosines. The period is going to be 2 pi over the number in front of x, 4, so it's going to be pi over 2 here. Then you're going to mark down, so this is the whole period, so 1/4 of the period is 1/4 pi over 2 multiplied to get pi over 8. So you start here at 0, then we go to pi over 8, then 2 pi over 8, which is pi over 4, then 3 pi over 8, and then it would be 4 pi over 8, which is pi over 2 here. And then the number in front is the 2, that's our amplitude. And there's no vertical shifts, no horizontal shifts here, so we don't have to worry about that. So we know my graph is going to come up to 2 and go down to -2. And then the 5-point method for cosine, it starts out high, medium, low, medium, high. And we draw one part of our cosine. And of course it's going to continue on here, but I don't want to have to draw too much here. Anyway, so we have our base 2 cosine 4x graph. Here's how we turn it into the 2 secant 4x graph. Everywhere that the cosine is 0, we go ahead and turn that into a vertical asymptote. And then we do the same thing we did when we learned how to draw regular secant. We just take these points that are on top of the cosine, and when we're in the reciprocal of it, we're going to get something like this. And continue these here, and this is going to be the graph of your secant here, reciprocal cosine. And the reason why, now I can mention why we didn't reciprocal this 2 here, because 2 cosine 4x is going to have a y value of actually 2. And 2 secant of 4x, the value you get when you plug in, say, 0, is going to be 2. So if I want the red graph and the blue graph to meet up, I take the reciprocal of secant to get cosine, But I would not want to reciprocal the 2 because then your cosine graph would only go up to 1/2, whereas the secant graph is still going to go down to 2. So it's just, you just reciprocal the secant or cosecant part to get cosine or sine. Leave the front number alone. You draw your sine or your cosine using the rules from before, and then you figure out your vertical asymptotes, and you go ahead and make your secant or cosecant graph. Hopefully this isn't too bad. These functions we don't really graph by hand too often, so I wouldn't worry too much about them, but it is something you should know how to do.